So right now we're going over your homework on page 8. And we had already talked about a couple of these questions at the end of class yesterday. I didn't tell you they were going to be your homework questions. So hopefully at least the first two were fairly simple because we went over them already. You had to do the title on your own, and then we started the depths during class, but then we ran into some trouble. So let's start here. What is the dependent variable? Which one is the dependent? Somebody raise their hand or I'll just call on you, Olivia. That is the number of oxygen bubbles. That is the dependent variable. How did you explain that that's the one you picked as the dependent variable? That's a perfect way. You cannot control it. That's one perfect explanation. You can't control it. You have no power over a plant to say, make 18 bubbles today, would you? You can't do that. No matter what you do, you can't change the number of bubbles a plant makes. Like, you can't tell it what to do. But the other way of explaining it is it's the one that depends on the independent. I like Trenton's way of explaining it better because it's simpler. But the number of bubbles depended on how deep the plant was. It wasn't vice versa. So on that same note, which one was the independent variable? Depth. And Remy, why is that one the independent variable?
Independent variable is the variable you do not control.
Try that again.
You do control.
You do control. Depth is the variable you can control. And how you control depth is you decide how far down you put the plant. Did you put it 1 meter or 10 meters or 50 meters under the water? That's how you can control the depth. What title did you guys give this? Jenna, what'd you put for your title? That's pretty good. There's one part missing from that. I'm going to take yours. Now remember, the rule for titles is you need to be able to just glance at the title and know what the graph is going to be about. There's just one thing missing from this title. Yeah. Something about depth. You have to include that this is a graph about bubbles at different depths. So I'm going to just say oxygen bubbles released by plants at different depths. So double check your title. If your title didn't include something about both bubbles and depth, adjust your title. Who's not sure if their title's okay? What'd you write, Phoenix?
Earth science.
Earth science? Okay, did you change your answer?
Okay, yeah.
No, that has nothing to do with what this graph is about. So I have to be able to look at the graph or the title of your graph and know what your graph is about. Telling me the graph is about earth science. In fact, this isn't even about earth science. This is about living things. Yeah. Did you change it now? Okay, let's try another one. Landon, what did you write? Works. What did you write, Sam? Okay, what did you forget to write? Something about depth. Did you change your answer? So why didn't you tell me that part? I want to know what's written there now. Okay. Thank you for allowing me to put a few of you on the spot. Thanks, Phoenix. I appreciate it, Sam. Thank you, Landon. So guys, when I go over the homework, it's not just to listen to me talk. You need to be changing your answers so that your answers reflect what you're supposed to be doing and knowing. So you need to be able to, if you flip back and you're like, okay, what's a good title? It needs to include an example or something that says what the graph is about, not earth science. Okay, so change your answers. Now the next part, this is where I got a whole bunch of you not following the #1 rule of earth science. And again, I'm going to say this all year long. The #1 rule of earth science is to read all the words and do what it says. So it's super easy for me to see who didn't read. If you only had one number here, what is the average depth? And most of you had the correct average, by the way. But then you did not keep going. So it wants, what is the average depth? Then the average bubbles for plant A and the average bubbles for plant B. And you had to round it to the nearest 10th. Right there. So this question was worth 4 points, 1 for rounding, 1 for having all 3 of those averages. So if you didn't do that work, you don't get it. You're going to lose points. So those of you who didn't finish, you only had one answer there. You lost some points for not doing everything that was there. Why I'm going to really emphasize this, especially for the rounding, it's going to be listed at the end, just like that. It will usually be the last sentence in the directions. You know, those things that sometimes you don't read. If you don't read them and you just either don't round at all and just put whatever you want, or if you round to the wrong spot, if it says 1,000 and you round to the 10th, I have to mark your answer wrong, even if your number is the right number. Even if you rounded it correctly to the 1,000, I still have to mark it wrong because you didn't read all the words and do what they say. So right there, it's going to hurt your average if you don't read all the words. I'm going to be very strict on that this year. So as I was walking around, I told a few of you to finish this up. So hopefully you were. Let's just go through the depth one first so that you know how to do averages. So we started this together, or at least I kind of gave you the idea. So you were supposed to take all of these numbers and add them up. Guys, I always have calculators. They're right over there by the fire blanket. Your phones have calculators. Your computers have calculators. I know you can do math, or at least you should know how to do math. Then fine, you know how to use a calculator is what I'm getting at. You don't get bonus points for doing math in your head. You don't get bonus points for doing long division. You only get points for getting the right answer this year. So what I'm telling you is use a calculator. No need to stress your brain and hurt your brain doing extra work when you have a calculator available. So here we go. To do average, you would take 1 plus 5 plus 12 plus 18 plus 28 plus 30 plus 35. And that gave me an answer of 129. Is that the average? What do I got to do now? Divide by 7. Where did we get 7? 1, 2, 3, 4, 5, 6, 7. So 129 divided by 7 equals 18.428571. But the directions told us to round to the 10th place. Do you guys know which one is the 10th place? It is the first number after the decimal point. If you're not sure, how I remember it is the number 10 has 1 0. So tenths is 1 number after the decimal point. The number 100 has 2 zeros. So that's the 100th. I probably spelled that wrong. That means there's 2 numbers after the decimal point. And the other one we're going to do this year is 1,000. So if there's 3 zeros in 1,000, thousandth has 3 numbers after the decimal point. And like I was saying, if you round wrong, I can't give you points. So you could go through, and if this was your right answer, and it's clearly the right number, but you round it wrong, I can't give you credit. So we got to go to the 10th place, which is the 4. I'm assuming you guys know the general rules of rounding, but I'll go through it real quick. So the 4 is the number we want to either keep the same or round up. We tell about the 4, we look over at the 2. The 2 tells the 4 to do what? Stay the same or round up? Stay the same. So the average depth is 18.4 meters. That was only worth a third of the point there, or a quarter of the point even. 18.4 meters. Then you had to do the same thing, and I know I just did the math in my last class for that one. Actually, I didn't do it for plant A, bubbles for plant A. Did anybody actually remember to read all the words and do them? What'd you get? I also got 26.7 for plant A. For plant B, this one, just because, I must not have, I did write it down. When I added them all up, I got 209. What do I divide that by? 7. Still, there's 7 numbers. 1, 2, 3, 4, 5, 6, 7. So when I added those up, I got 209. And I divide that by 7. Let's look at that number. 209 divided by 7. 29.857142. So again, we got to go to the tenths. That's the 8th, or the 8. What does the 8 do? Does it stay the same or round up? We got a 5 here. What does the 5 tell the 8 to do? Go up. Anytime you have a number 5 or higher there, you round up. So what did I say? It was 29.9 for plant B. Oh, that's for plant B. So do you have those numbers written there?
Yeah.
Did you do something wrong? Do you know what you did wrong? Okay, so make sure you check your work and know what you did wrong. Is there anyone who's still not sure what they did wrong? Okay, I know we said we weren't going to do the graph, but I just want to kind of double check that we remember what to do. So we're not going to go through and plot it. The plotting, we're going to do plenty of plotting in lab. If you've already been in lab, you and meet with me at least. Did anybody have Mr. Meeg already for lab? Did he start it today? Okay. So we're going to do plenty of plotting in lab that we don't need to practice the plotting. I will, however, tell you that, guys, you have to be super accurate when you are plotting. One thing that I see kids kind of doing sometimes is kind of eyeballing it. And if you have a number that's down here, you might eyeball it. Like if I wanted you to put your number on this line, follow that line all the way up with your pencil so that you don't kind of go whoop and end up over here. So it's really important, because here's what they do when I have to grade a lab or grade a graph, is they give me a clear copy that fits right over your answers. Now the answer, like if your answer was supposed to be right there, what they do is their clear copy will have a circle around that. And it's a circle like that big, like it's not a huge circle. So your answer has to be within that circle. If it's not, you lose credit for the whole graph. So you do have to be as accurate as possible. But what I want to remind you is, where does the independent variable go? The one that I can control. We did this yesterday. Does it go on the X or the Y? Everybody give it a moment to, actually, how about this? Everybody go back to the reading and find in the reading which axis the independent variable goes on. Find it in the reading. Everybody point in the reading where it is. Yep, what paragraph is that in? That Right there, oh, I already underlined it. This variable is placed on the x-axis. The independent goes on the x. So on your graph, this would be the independent down here. Again, I am assuming, but I'll remind you that the x-axis is the horizontal one. Chris? Which, by the way, again, which one was the independent, the sunspots or the years? Oh, we're wrong lab. That's lab. Depth or number of bubbles? Depth. So this is the depth. Which means dependent goes on the y. And that was the number of sunspots. Oh my gosh. Guys, that's what your lab's about if you weren't already in lab. So bubbles, number of bubbles. I blame the Bills game. I was up way too late. Not that I was watching it. Not that I care if they won or lost. I mean, I want them to win, but my husband kept me awake watching the Bills game. Anyway. This is what you're going to have to do in lab. If you didn't know that already, this is what you might have to do on the Regents is you might have to make your own graph from a blank sheet of paper. And next part, just like in lab, is you're going to have to number these axes. I'm not going to have them done for you. So to number them, you have to count sometimes. You have to count on your own. Anybody remember some of the rules for numbering the axis? What do you count by? Let's start there. What could count by twos? Could count by anything else? Could count by fives, ones, tens, 20s, hundreds. What did you say? You could count by halves. It's not wrong, but here's my rule. If it's hard to count by them in your brain, don't count by them. So somebody that's counting by sixes on the lab today, count by. Like, you know what I mean? Like, I know how to count by twos without thinking. 2, 4, 6, 8, 10, 12, 14, 16, 18. Same with fives, ones, obviously, 10s. 20s, 20s I can still handle. It's like 2 with a 0. I don't count by threes very often. I can if I have to, but that's like not second nature. I certainly don't count by sixes. I don't count by fours. So always count by something you're used to counting by. With the halves, I still like to think if you were doing halves, if you did 0, skip a line, 1, then yes, you're technically counting by halves. This is totally acceptable too. So just count by something easy. Don't count by threes. That's hard. Definitely don't count by sixes. But one thing you do have to be careful about is when you're labeling, you can't jump around with what numbers you're using. You can't be like, okay, ones are working pretty good for the first half and then switch to fives. You have to stay either counting by ones or twos or fives the whole way across. Same with the Y. You can choose a different scale for this one. So if twos worked for the X, you can use fives or tens for the Y if it makes it easier. And then just remember, you need it to take up the majority of the graph paper. If you don't go past half, so if your numbers stop like here, you got to redo it. We needed to take up the majority of the graph paper. So that's graphs. The Regents this year is going to ask you to be able to do that. Make a graph from a bunch of data. The next thing that they're going to do is on the next page here, page 9. And it's called interpreting a line graph. What does interpreting mean to you? If there's a sign language interpreter in the room, what are they doing? Translate. That's a perfect way of explaining it. They're taking my spoken words and turning them into sign language so someone who can't hear can still They're translating for that person. They're making it so they can still understand what I'm saying, and then vice versa. So same deal here. Basically, it means translating a graph into words I understand. So it's basically reading the graph, basically. So again, remember, number one rule is to read all the words. That includes reading a picture. If the picture's a graph, you need to be able to read it. There's a system for reading a graph that will make the graph make more sense. So since the independent variable is always on the X, the one that you're controlling is on the X, and the one that depends on that is on the Y, there's a specific system for reading it that will make sense. Let me show you why. Oh no, I'll get there in a second. And here's the system. The system says when interpreting a graph, read the bottom variable first, so the X-axis. And when I say read it, you're literally just going to read the words. So in this case, it's going to just be B. Now, what do you guys know happens on the axis the B axis as we go from left to right? What do the numbers do? They always increase. The X-axis, when we go from left to right, the numbers will start small and get bigger. So that means as we read this, we're going to read as B increases, as B increases. This is your independent variable. Then you're going to read the side variable. So in this case, A, and then you describe what the line is doing in the center of the graph. So in this case, you read the X as B increases. The X is always going to increase. Then you say the letter A, and then you read the graph. So as B increases, A, that's an up line, also increases. So I want to kind of set up the system we're going to use for this. So we're going to say, do you have room right here? Yeah. Okay, so as blank, which we're going to label blank as X axis, and it's going to increase. So as X axis increases, the X axis will always increases. Then we say the Y axis, so Y axis, and then you tell me what the line is doing. Read the line. So again, using this example one here. So this did say B underneath the word small there. So as B increases, A, read the line, increases. If you use that system, you will always get it right. So let's try it on this next one that has temperature and pressure on it. I already started this one for you. As temperature increases, so that's the X. So as X-axis temperature increases, read the Y, that's pressure. What's the graph doing? Increasing. So that one, I kind of got it started for you. Now I want you to use that same system. Try the next one. Try that, do the whole sentence on your own there for that one. No, you got to do it my way. You got to, you have to follow the system. So you read as X-axis. So what's the X-axis? In this graph. No, that's the Y-axis. Yeah. Yeah, so erase all. Yeah, so what time do you go? We have times you have that. I'm not saying the same. What does that say to the x-axis always does? And then, yep. That is a great question. Okay. So we gotta follow the system. So I saw a bunch of you still just trying to do this on your own, and I knew the flat line was gonna throw you off. The x-axis is always increasing, no matter what. So to start this one off, what is happening to the, first of all, which one is the x? The bottom. So as time, what is time doing on the x-axis? It always increases. There's no thinking here for this one. So it's always increasing. So as time increases, then we just read the y. So then we know that the next part is temperature. Then you read the graph. What does a flat line tell you about? Is it increasing, decreasing, or staying the same? That's the staying the same. Temperature stays the same. Try the next one if you haven't already. Follow the system as x-axis increases. That's so just replace x-axis with the words. Okay, so in this case, we've got as what? Would you write? Phoenix, you had this one I saw. You got it. As temperature increases, if you guys want to use arrows for your, wow, apparently I can't draw an arrow. Oh, maybe I should just write it. As temperature increases, density decreases. Did you already finish up the other two? I'll give you like 30 more seconds because a couple of you didn't. That's empty. Olivia, do you have the next one? Density and volume.
As volume increases, density decreases.
Yepers. As volume increases, density decreases. Remy, I think I saw that you had, oh, you want to do it, Chris? Sorry, Chris volunteered. Yep. As long as you follow the system, you'll always be able to see the connection. And that's why it matters where you put the independent and the dependent. Again, temperature in this case, what's changing is as time marching on, the temperature is the one increasing. Time is controlling the temperature. The temperature is not controlling the time. So it is important which one goes where. The one that you can control goes on the X. So speaking of that, so like I said, the Regents is going to ask you to be able to make a graph, read a graph, and then take those relationships where the temperature, where we're reading the X, doing the Y, and then draw them. But so basically what I'm saying is the reverse of what we just did. So they're going to give you the independent variable first. So this is always, what comes first is always the x-axis, and then the y, and then the line. So on here, we have two labels. So as depth, so we do have to put depth here. Increases. So the x-axis is always increasing, and then we put pressure on the y, and then we draw a line for increase or decrease. So increase is a going up line. And the way to tell which way the line goes, imagine yourself walking this line. You're going uphill if you're going from left to right. Downhill, that would be a decreasing. A flat line, you're not changing. It's a flat hill, or not a hill, I guess, flat road. Do you guys think you got this, or should we do another one together? All right, why don't you knock them out? We'll come around and check. Oh, man. I'm literally reading that. I should mention that we do have a quiz tomorrow. We're gonna do a little bit of practice before we leave. It is on observation, inference, prediction. I originally said it's on graphs, but I made the quiz this morning and there's no graphs on it. So it's just on observation, inference, prediction. A mixture of just making observations, inferences, predictions, and Regents questions. So similar to those pages we did in our packet. All right, let's see what you had to say for this. As depth increases, density increases. What goes on the X? Depth. What goes on the Y? Density. Which way does the line go? Up. As depth increases, density increases. So x-axis, y-axis, draw the line. What do we got for altitude and temperature? Where's the X? Or what's on the X? Altitude. And that means temperature on the Y. Which way does the line go? Down. Population increases, pollution increases. Population, pollution. And which way is the line? Up. How about the amount of studying increase? As the amount of studying increases, the grade increases. Studying here. And grade. And that's an increase. How about time velocity stays the same? Yep. So we got time, velocity, and a flat line. Guys, it didn't matter how hot you could have put your flat line down here or up here or somewhere in between, as long as, and that's a flat line despite what my graph looks like. It's supposed to be a perfectly flat line. So those are the three different things you're going to have to do with graphs. Make them, read them, sketch them. We'll practice more with this in lab. You'll get more comfortable with it. You have no homework tonight other than to study. So speaking of studying, let's do one. We got just about 3 minutes. So not much time, but we'll go ahead and look at another picture and see. Okay, why are we not? There we go. And see if you are able to make some observations, some inferences, or some predictions about this picture. What do we have to do to make an observation? Look at it. In this case, we're just looking. Yes, if it was in this actual room, you are using all 5 senses. Alex, what did you have something to say?
Oh, I predict she's about to die.
Give me an observation first.
Oh, okay, sand.
There's sand. Who else has a couple? Sam,
People in the back.
there's people in the background.
Water.
There's water. I love it. No one said the ocean. Because why saying that's the ocean? Why is that not an observation? Because it might not be. It is, but you didn't know that. This is in New Hampshire. So the observations, no thinking, just looking. Give me an inference, a guess based on this. It was hot. What made you think it was hot? The sun's out. The clothing they're wearing. The fact that they're on the beach. People don't typically go to the beach if it's cold. Perfect. Give me another one, somebody. Inference, a guess. There could be sharks in the water. What made you think that?
Water.
Because there's water. There could be sharks. Gosh, I hope there wasn't. Did anybody make the inference that she likes cats? Why is that an unacceptable inference based on this picture? There's nothing in this picture to make you assume that. You have to make a correct, to make a good inference, it has to be based on something you see here, not just a random guess. Yeah, Alex already gave us a prediction she's going to die. Why did you say that? Because she's floating in midair upside down, she's gonna fall, break her neck. Okay, that didn't happen. But an acceptable prediction, a little morbid, but acceptable. Can anybody else give me another one, Chris? That's not a prediction, that's an inference, because it's not about the future. You could say this is written is going to do this next. While I may have been able to do splits, I could not do them upside down. Pretty sure I still can't do a split since the one during the pep rally, because I hurt myself. Okay, I definitely tore a hamstring that day. Did not mean to go all the way down to the ground. I had been stretching during my planning period and made the decision in my head, I'm just gonna go down in a little split. Got caught up in the moment and went down way too fast. All right, guys, your quiz is on this type of stuff tomorrow.